we're going to talk about the principle of relativity. Now, in general, the principle of relativity says that all laws of physics are the same in all inertial reference frames. So, let's consider a problem. We have a person, call them A, standing still at a point, a train stop. Now, we also have a train moving away from them with another person called B in that train. Now, these are two different inertial frames of reference because the velocity within these systems is constant. There's nothing changing. So, A and B are going to view things differently. A sees B moving away from them at a speed. B sees A moving away from them at a speed, but the other way. So, we have to refer to these from two different reference frames. Now, we're going to call A the home frame, where all events occurring according to A are going to be different than they are according to B. B, we're going to call the other frame, which is the actual moving frame of the train, where B is at the origin of this moving frame. According to B, they're sitting still, but they're moving at a velocity. So, if B is moving at a velocity v away from A, then we know that A sees B is moving, B sees A is moving. So how can we solve this conundrum? How do we see these two different events differently? Well, first, we're going to introduce SR units, where if we know the velocity of the train is v in non-SR units, then in SR units, this velocity is going to turn into the velocity divided by the speed of light, c, 3 times 10 to the 8th seconds. So we're going to call this new unit beta, where beta is the velocity of the train in SR units. So, now that we know the velocity of this train, how can we draw a graph of the motion of these two on the same axis? Well, to start, we can consider, this is from the home frame. This graph I'm going to draw is according to this person, A, who is in the home frame. So, this axis is going to be our time axis. This axis is going to be our position axis, x. Now, the time axis is, of course, in a unit of time, seconds. X we're also going to make in units of time, seconds. As you can see, we can take the position of something in meters, call it like 3 meters. If we divide that by the speed of light in meters per second, we're going to end up with a certain number of seconds. So that's how we can say position in units of time. It's a little confusing, but in this case, we're going to use it. So, now, this is the home frame graph. This is how we graph motion according to the home frame. How do we do it according to the other frame, B? Well, B, if B is moving at a velocity of beta away from A, we know per unit time, let's say this is a unit of time, that B is going to move beta away from that. Beta, a distance of beta. So, if we move this over here, say this is beta, then we can draw this new line with the slope of 1 over beta, which we're going to call T prime. This new line is the T prime, which is the T prime line, which is the time frame of the other frame. So, T prime is a new line, which I think of it in concordance with the T frame, where the time is changing, but the position is all staying the same. So it's all events that happen in the same place at different times. So x prime equals 0. Now, what is x prime? X prime is our new axis of position for the other frame, which is in reference frame from frame B. So the x prime, thought kind of the same as the x frame for the home frame, as the x-axis for the home frame, is going to be all events that happen at a certain time, in this case the time t equals 0. So let's say in this train make it a little bit longer so that I can draw this. Let's say in this train you have two events happen. You have event A and event B. And this is where two people are standing up in the train maybe at exactly the same time according to person B. So this person sees two people stand up at exactly the same time. Now, is person A going to see these events at exactly the same time like person B does? Well, let's see. So since these two events occur at the same time, this is our axis for the other frame for all events that happen at one time. So at time t equals 0, event A happens, and event B happens. They're at different places, as you can see, in front of them in front of person B on the train, but they're happening at the exact same time. So along this axis. So delta t prime in this case equals 0. Delta t is the time frame as the time axis for the other frame. A and B happen at the same time. The difference in time between A and B is 0. So delta t equals 0. Now, basically our question is, does delta t equal delta t prime? Well, looking at this graph, we see a distance here, we see a distance here. What is this difference in distance? That's going to be our delta t. Does that equal 0? I don't think so. So delta t does not equal 0. Is that greater than or less than 0? Well, clearly delta t is a number. Delta t is not less than 0. So proven from this graph, delta t is always greater than delta t prime. So an event that happens at the same time in the same universe is seen differently from one reference frame, the other frame, than from another reference frame, which is the home frame. This person sees A occurring before B. This person sees A and B happening at the same time. Very weird, but true.